Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In today's session, I want to talk about something that seems trivial, but I found that some students have slight trouble with it, which is how do we calculate areas or surface areas and volumes? So before I start, let's talk about just the length. How do we measure the length? Of course, yeah, straight edge, right? But what is the concept itself? For example, I could draw a line and I tell you this is 1 unit. 1 unit. What does that mean? Unit. What's unit? Do you know? Unit comes from the word one. In French or in Spanish or in Italian. Excuse me. So in French, for example, we say one is un, or if it's feminine, you say une. Une and unité, which is unit, comes from the word one. And even when you think about what's the meaning of united, like we have 50 states that unite together and form one country, one federal government. So unit is one. Now, some people in Europe, they divided, like in English, the British, they used the US customary system where we measure the distances in inches. So they agreed on a specific length and they called it 1 inch. The French and the rest of Europe, they used what we today call the universal system of units, and they use the centimeter or the meter, really, but the meter is too long, so we say a centimeter. So when I say a unit, I mean this is one of what? Well, I didn't specify. But if I make it the length is what we agreed upon as an inch, then it would be 1 inch or a unit inch. And that's why we call the inch or the centimeter, we call them units. Really, that's a little confusing because when we say a unit of centimeter, meaning it's a 1 centimeter. So if I extend this line and I make it 4, for example, so I use this distance as 1, so I'm going to quadruple that. Okay. And come here and say, this is 4 units. So if the original unit was a centimeter, these would be 4 centimeters. If it were an inch, we call that 4 inches, and so on and so forth. And you say, what does that have to do with areas? No, it doesn't have to do anything. I just wanted to introduce the term unit. And something else. Do you think the length of this will change if I turn the page like that? Or if I make it vertical? Or if I make it inclined in any way, shape, or form? Yeah, this guy is crazy. What is that? What's this question? Of course not. So the orientation of the line didn't change its length. So notice that the length also is what we call one dimension. I can draw a line along the x-axis or along the y-axis or along any inclined axis. That's important. Now, so we say this is one dimension and we call it length. But I can construct geometrical figures. One of the easiest one is what we call a square. And I can call that, if I make any unit, the size is any unit, of course, they would all be 1 unit. So we call it 1 square unit. And this is 2 dimensions. And that is an area. So if this is 1 centimeter, I will call it 1 square centimeter. So let's say it's a centimeter. I'm going to say it's 1 square centimeter, but mathematically, we usually write it 1 centimeter. And you know why now we call this power square? Because that's a 1 square. And it's a unit square. So we call it 1 square unit, or 1 square centimeter, or 1 square inch, or 1 square mile, and so on and so forth. Okay, bear with me for a second. Now I'm going to draw a square, a big square. And let's say the size is 4. And I ask you to find the area. No, I don't care what you memorize. I don't want that. 2 ways I can measure this area. I'm going to say, okay, I know that this guy is 1 square unit, or 1 square, 1 square unit. So let me take this and place it here and see how many of this guy will cover the whole thing. So if this is 4, let me divide it into 4 columns. And if this is 4, of course, they are not drawn to scale. I'm going to divide it into 4 rows. So each one of those is 1 square centimeter. So I can count and say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I do like kids when we ask them to count. And then when they grow a little bit, they say, no, we have something called multiplication. It's a quick addition. You don't need to count them all. You need to learn your multiplication table and know that 4 times 4 is 16. So we say the area of a square is the side square, right? So it's 4 square units or 16 square units. Again, if that was an inch, I would say 16 square inches, because each one of those, if that was an inch, I will call it 1 square inch. And I have 16 of them, they would be called 16 square inches. So far, so good? Okay, now to something you didn't learn, or we take it for granted you would understand it, but maybe you never thought of it. I'm going to show you something. I'm going to draw a line, a straight line that has a length, say, of 3. And I'm going to say this is 3 units. The units can be, as I said, centimeter, inch, yard, meter, it doesn't matter. And then I'm going to move this line parallel to itself, meaning instead of being here, I'm going to move it up here, for example. And let's say I'm going to move it up a distance of 4 units. Or maybe I didn't want to do, let's say 2. Okay, because I didn't want to make it a square. 2 units. Okay, move it 2 units. And I ask you, what is the area of this rectangle? Again, I can divide this into 2 and this into 3 to make each one of those a square unit. And I will have 6 of them, because if we call that B and we call that H, base and height, then the area of the rectangle is 3 times 2 equals 6 square units. And then it turns out that because the length didn't change, all what I have to do is to take this length and multiply it by the distance I moved the line up or down. And then one student can tell me, suppose these 3, I move them parallel to, I move this line parallel to itself, but not vertically up or down. I'm gonna make it incline. So let's see. So if these are 2 units here and 2 units there, this is a very powerful concept you have to understand. Here's a line parallel. This line is 2 units away, so that distance here is 2 units. Above or below, it doesn't matter, 2 units. And this is 3 units. But now instead of moving the line like up, exactly up, now I'm gonna move it sideways. Like that. And then I'm gonna move it parallel to itself and make a parallelogram. You know what the rule is? It doesn't matter how, if I move a line up 2 units vertically or inclined in another direction at another angle, I can make it like this and like this. All of them will have the same exact area. So now I really don't need to memorize, oh, the area of a rectangle is base times height. I can see it. I have a base and I move it up. So all what I have to do, if this base doesn't change, it's 3 here, it's 3 here, it's 3 here, and I moved it a distance of 2, so 3 times 2. Same thing. This distance is 3. If I go up like half a unit and measure it, it's still 3. It's still 3. It's still 3 all the way. And the total distance I moved this line up was 2 units. So the area is still 3 times 2. Now you see it that I can draw a rectangle and this parallelogram and another parallelogram and a fourth one, and all of them will have the same exact area. Okay, now let's look at the triangle. Because many times I've seen students who would find the area of a triangle, they multiply base times height, and they forget to divide by 2. But the question is, why do we divide by 2? Now, let's look at a triangle, any triangle. It doesn't a scalene, so it doesn't have to be an isosceles or equilateral or right triangle, just any triangle. And the height here is h. So from this point to that point, doesn't matter the numbers, we are going to call that h, and this is b. Why do we divide by 2? Well, we can show it geometrically. For example, I can drop a line perpendicular to the base here. I'm not going to construct it with the compass. I'm just showing you. It's not. You can always see that I constructed 2 rectangles, a left one, and I had a diagonal that splits it into 2 equal parts, and a right one. I drew the diagonal, so I split it into 2 equal areas. The rectangle is made of 2 circles and 2 crosses. The triangle is made of 1 circle and 1 cross, so it must have half the area. So it's so easy to see why it's half. Another way to look at it is to say, well, the base at the bottom is b, and at the top is 0. And it's decreasing linearly. So there must be a point where I can construct an area of a rectangle equal to the area of this triangle, and common sense will tell you at half the height, because at half the height, you should have learned that in geometry, if that height is half of that, then this base is half of that, or b over 2. So I cannot use all b because that would be the whole rectangle. I cannot use 0 because 0 gives me an area of 0. So it must be midway. It's b over 2 times the height. So we know the area is 1/2 base times height. What if I have, even by the same concept, and this is, I will stop here, and then next time we'll talk about volumes the same exact way, because I don't want you to memorize. I just want you to understand, and or maybe I will show you something else after the trapezoid. So we are going to call that B1, first base, second base. No, it's not baseball. And height. You see what we did here? We say at the bottom it was B, at the top it was 0, and it's decreasing in a linear way. So midway it would be B over 2. I will use the same concept here. I could construct a whole triangle and say the area of the big triangle is B1 plus 0 over 2 times the height, and the area of the small triangle is B2 plus 0 over 2 times the height. I subtract them from each other, and I will get B1 plus B2 over 2 times the height. Or I could have said, how did I find B over 2? I took the average of 0 and B. Here, I'm going to take the average of B1 and B2. If this is 10 and this is 6, I'm going to take 10 plus 6 over 2. So the mid point, it would have a distance or a width of 8 times h. And basically, that's it. That's how we calculate the area of a square or a rectangle or a triangle or a trapezoid easily and with common sense. Now, the only thing remaining is a circle. You know, of course, many of you already learned that the area of a circle is pi r squared, but what is pi? And please don't tell me 3.14. I know you memorized 100 digits and I don't care about that. That's not what I'm asking. I'm asking, what is pi? What is it? Not what its value, but what is it? Because I don't think, or when I asked many students, no one told me that it was explained to you in school. It's just they take it for granted. You know, they tell you any circle with a radius r, its area is pi r squared, and its circumference or the perimeter has a length of 2 pi r. Yes, that's fine. But how? For the area, it might be a little difficult to explain it now, but when you take calculus, you will see it's so easy to prove it. But what about, say, the circumference? If I draw a circle with a radius r, oops. When you take trig, you will hear the term radian. Okay, so when you open your graphing calculator and well, I don't have it here, but or may have one, an old one, like doesn't matter because I'm not using it really. Okay, so when you go to mode, you can see that next to the angles, you have angles in degrees or angles in radians or grad, but don't worry about that. Degree and radian. So what is a radian? What is 1 radian? Oh, I don't know and I don't care. No, you do. You should care. Okay. If I take, this is the radius r. And let's say R, for example, is 5 units, whatever, R. I'm going to get a small piece of thread or wire, and I'm going to measure a distance R here as the radius, okay? And then I'm going to turn it around like that until it stops. And I'm going to say, okay, so now I have a radius of R and an arc of R. So it looks like a piece of pizza where somehow this distance is the same as the radius. If that's the case, we call this angle 1 radian. Okay? So when we try to measure how many radians, I want you to remember that. It may become helpful later. How many radians exist in half a circle? We found that we have pi radians. It's not exactly 3, slightly more than 3, 3.141592 as you memorize. So there are pi radians in half a circle. Or 2 pi radians in a whole circle. So if each radian gives you R, 2 pi radian will give you a distance of 2 pi R, right? How many R's exist in a whole circle? There are 2 pi, because there are pi in half a circle, so there must be 2 pi R in a whole circle, and that's it. So the word pi here is the number of radians in half a circle. And what's a radian? A radian is an angle in a circle in which the length of the arc is exactly equal to the radius. Radius, radian, so you remember it. Okay? I think that's enough for today. I didn't want it to make it long, and it became long anyway. And next time we are going to look, and of course, when you calculate the area, you will need something more advanced. So as I said, the area of the circle is pi r square. But we can discuss that maybe in another course. But for now, that's how we understand how to calculate an area in what we call uniform shapes, like a rectangle, a square, where parallelogram, where the distance, the base doesn't change, the length of the base doesn't change, in which case, I don't care if it's vertical or inclined. All what I care about is what is the vertical distance that this base has moved up. It moved up 2 units, so 3 times 2 is the end. And that's why here we found why the area of a triangle is half a rectangle, because I have a whole rectangle. I can break it into 2 small rectangles that are equal. In fact, we call congruent. So the sum of these 2 is half of the sum of all 4, right? So that's why we take, or we take the average of the top base and the bottom base. But if the top base is 0, then the average of b and 0 is b over 2. B over 2 times h. If it's not 0, then it's b1 plus b2 over 2 times h. And finally, we talked about the radian and the circumference of a circle. Okay, I hope that clarified some mistakes or something that was unclear to you. If you have any questions about how we calculate these areas again, or something else you wanted me to go over, I would love to hear from you. Thank you very much for your time. Hope to see you soon. Bye.